starting by completing the square again, example number 2. So first things first, we need to make room to make this a perfect square trinomial. So write x squared minus 2x plus blank. Move the 6 to the other side and put a blank over there also. So to move it, we had to subtract 6 and then put a blank. Alright, so then we figure out our value for c that would complete our square. So we take half of b, so b is negative 2, divided by 2 would be negative 1, and then we square that number. So that gives us 1. And then we rewrite it, and we just need to rewrite it as a binomial squared this time. So notice on example 1, we know that after we make it a perfect square trinomial that our factors are going to match. Knowing that we're going to have matching factors, we can kind of skip some of that work. And we can just put x minus half of b. b was negative 2, so half of that would be negative 1. It always works that way. So that's kind of a little trick. So then bring down what's on the other side. Negative 6 plus 1 would be negative 5. And now we need to finish solving. So we have x minus 1 squared equals negative 5. We got to get x by itself, so we have to take the square root of both sides. So then x minus 1 would come out evenly. And then we have plus or minus the square root of negative 5. Now normally we don't take a square root of a negative number, but now that you're in Math 2, we're going to actually go ahead and move forward with that negative. So we have a little value we call I. Let me introduce you to I. I equals the square root of negative 1. And so what we can do is we can say the square root of negative 5, I'm going to move it up a little bit, that we have in our problem now can be rewritten as the square root of negative 1 times the square root of 5. And then if that is equal to I, we can just put it out front. So long story short, when you have a negative under the radical, you can put a little I in front and then write it as if it's a positive number underneath. And that's really the main thing you need to know about that little I. It's equal to the square root of negative 1, so it helps us to work with those complex solutions is what they're called. And then we just need to finish solving for x. So we just have to add that 1 to both sides and then put that all together as 1 plus or minus I square root 5. So you might think, what in the world is that? Well, that is where we have a graph of a quadratic. Let me just give you a little sample here. And sometimes our quadratic does not touch the x-axis. Well, it actually has 2 complex roots, is why it's not touching that x-axis. They're imaginary or complex is what we call them. So that's where that little I comes in handy. And that is it for example 2.